Hey there, and welcome to the Noesis Interactive Character Design and Integration with Half-Life 2. We're going to focus on importing characters we've created into Half-Life 2 Deathmatch. Following discs, we'll also explore advanced character design and map creation, as well as integrating characters into other games. So to get the most out of this disc, you're going to need a licensed copy of Half-Life 2 Deathmatch, a working version of Photoshop, trial versions of which are available from adobe.com, and Softimage XSI, the 3D software package we're going to be focusing on. A trial version of XSI is included on this disc. If you don't currently have Half-Life 2 Deathmatch, you could buy it online from steampower.com. Just go to steampower.com, select Games, browse through their games, multiplayer games, and choose Deathmatch. I got a couple different versions you can choose from. If you don't have Steam, you're going to need to download that first. So click Get Steam and download it now. The installer is pretty small. And the interface is going to allow you to download any of the games you'd like from Valve. This DVD also includes a 30-day evaluation of XSI 5.1 Foundation. So explore the DVD. Go to Installers, XSI Foundation, and let's give it a double click to install. When the setup launches, just use the recommended install options to guide yourself right on through. And when you're finished, we'll explore some more of the DVD contents. Here we have the Databases folder, which contains many of the necessary files for completing the lessons on this disk. The folder should already have been copied to your computer during the install, but if you need a backup copy of any file, you can go and copy the folder contents directly to your hard drive. Inside is a folder called Extras, which contains many of the models, materials, and other asset files that we'll be using throughout our lessons. And there's also a reference folder, where you'll find a nice PDF listing the useful shortcuts for XSI. Might want to print this one out and keep it nearby, just for a refresher. You can also create a shortcut on the desktop for the Extras folder by right-clicking on the file and selecting Send to Desktop Shortcut. It can make accessing the folder a little bit easier, a little more convenient during the lessons themselves. The first time you open XSI, it will ask you if you want to buy or continue your evaluation. For now, let's continue the evaluation. And we're going to link XSI to the databases we've copied to our local drive. Go to File, Open, and by default, we are in the XSI Samples database. Navigate out to the Noesis DB201 Scenes folder, and open the XSI scene to get us started. It'll ask you if you want to update your database. Let's select Yes. And now the next time that we open a file, we'll have both the DB201 and the samples databases available to us. I hope you enjoy the Noesis Interactive Mod Your World series. So let's jump right in and get ourselves started. Now we're going to discuss how to actually place the characters we've created into Half-Life 2. First, we have XSI, the 3D modeling program we're using to create our models. Then we'll use Photoshop, an excellent program really important to help us texture our characters. And to be able to export our models from XSI, we're going to need a specific plugin from Valve. The plugin is free and is downloaded through the SDK. There are also a couple other plugins in Photoshop that we can use to export the textures directly without having to compile them. Once we have a 3D XSI model, we can export it using the Valve plugin so that it is later ready to compile with the SDK. Here, we're going to work with our textures. The Valve SDK contains all the required tools to compile our different assets and modify the game. This is what we're going to use to compile our models and textures. And from here we have two options. The first is to view the model in the model viewer. This is an application that comes with the SDK where we can see our models walking, running, shooting. We can see how the textures are applied and watch the various animations. It's very useful for checking to see if our model is actually ready for the game, or if we're going to have to go back to XSI or Photoshop to adjust anything. And here we're going to actually play within a level. It can be Half-Life 2, Deathmatch, Counter-Strike, Day of Defeat, any of the other Valve games. Let's break down the process in detail. On one side, we have XSI, and on the other, we have Photoshop. With XSI, we will export an SMD file, then we'll create a set of instructions and a text file called a QC file. With these two files in hand, we can use the Studio Model program to export these 6 different pieces that will make up our compiled model. In Photoshop, we will create a TGA file, which can then be compiled using the vtex.exe program from the SDK to create a texture for the engine which our model is going to reference. I should also mention the triangle or polygon limits for the engine. In Half-Life 2, we have soldiers with about 4,600 polygons, police with around 3,800, the resistance with 49, zombies with 4,200, helicopters with 6,400, striders with 6,400, and Alex with the most, with about 8,200. So we can see that the characters generally made up about 4,000 polygons. Helicopters and vehicles have around 6,000, and characters with a lot of detail are made up of just about, a little over 8,000 polygons. The engine itself has a limit of about 25,000 polygons per model, and a limit of 2,048 pixels per model. However, if we're using the XSI 4.2 mod tool, we have a restriction of 7,500 triangles per character and 4,000 triangles for props and objects. In either case, this should be plenty. Let's take a closer look at some of the tools we'll need to mod our game. When you open Steam, the first thing it does is check for updates. A window opens with tabs for the store, where you can buy the game. You can always check back in here to see what's new. This section gets updated a lot. My Games, which are the games you already have, as well as the ones that are downloading or can be downloaded. And the Tools tab, where we find the SDK. If it is not completely downloaded yet, right-click and select Install Game, and then Download. Once it is downloaded, double-click and open it. When opening it for the first time, take note of the current game we have selected. In this case, we're going to be working with Half-Life 2, Deathmatch. It may take a while to get everything set up and copied over to the right folders. The next time you launch it, it should load much faster. Once the necessary archives have finished copying, go to the SDK window and close the Steam window. The SDK is made up of 3 key applications, as well as some documents and utilities that we're going to use. The applications are first the Hammer editor. Hammer is a Valve program used to create maps. If you check out our disc on level design, we discuss Hammer pretty in depth. The model viewer, which allows us to view our models and animations, and the face poser, which allows us to give some facial expression to our characters. Then we have some documentation, extra utilities, The Create a Mod option allows us to access the contents of the SDK, and links, where we have access to the Valve developer community and the Softimage XSI mod tool, if you want to download it. We're going to choose Deathmatch as our game right now. Then open your Windows Explorer. I have a slightly different version here, but don't worry. Go to C, Program Files, Steam, Steam Apps, then select your username, and here we have the games that we can mod, along with the source SDK and its contents. You'll see your own username here instead of Noesis. In the source SDK bin directory, we have all the source SDK applications, the Hammer Editor, Face Poser, Model Viewer, and everything else we've just discussed. Let's explore a bit more. Within XSI, we have the Valve Source plugin to import and export models. In Source SDK content, we have utilities for Counter-Strike, its specific maps, materials, models. Within XSI, we have a scene we can check out with the different characters. Urban reference, we'll discuss a bit more later. And then other folders for specific games, like Day of Defeat, etc., as well as a generic folder for shared files. In the Half-Life 2 folder, or HL2, you'll find animations, maps, materials, and models from Half-Life 2. You'll probably recognize them from the game. The airboat, the buggy. Inside Humans SDK, we have the animations for humans. Some more human models in different Half-Life 2 scenes. And just keep in mind that all these scenes can be opened up within XSI. You'll also find weapons, police. Okay. The source mods, which you can find under Steam Apps, are created depending on whether we're using an existing mod or if we're going to create one on our own. It will show up in this folder. Since we'll be modifying a mod, specifically in our case Half-Life 2 Deathmatch, we need to first make a few preparations. In the Deathmatch HL2MP, or multiplayer, folder, we need to create some new folders where we're going to be storing files. Create 3 new folders and name them Model SRC, as in source, Material SRC, and Map SRC. These are the folders where we will save assets we export from XSI and create models that can be initialized into the game. Within the SDK is the bin folder. We have some applications in there we'll need. The first one is the studiomodel.exe. This program actually compiles our models. We will simply drag and drop from the archive to the program so it can compile the models. We also have the vtex.exe. This will convert our archives to the type of textures that will run within the engine. So keeping those in mind, let's talk about the types of archives that we'll find or create with the SDK. The first one is the .vmf. VMF files can be generated by exporting a map from XSI or directly from Hammer. These will be saved and found in the source SDK content under the name of the game in the map source folder. Next, we have .tga files. These are different textures that we can apply. These will be saved within the source SDK content, name of the game, and materials source folder. The next files are the .scn, .smd, and .qc files. .scn is the scene that we will save from XSI. If we are using the XSI mod tool, we will save it as a .exp. .smd is the model file that we export from XSI using the Valve plugin, which we'll focus on a lot. And the .qc is a text file that we're also going to create, which contains some instructions the SDK needs to compile our models. We'll save these files under the source SDK content, game, and model source folder. .bsp files are fully compiled game maps. These are saved under the game maps. .vmt and .vtf files are compiled game textures. A .vmt is a text file that we're going to create, which is basically some more instructions on how we want our textures applied to the material. .vtfs are created by compiling our TGA files. These are saved in the game materials folder. .mdl and .vtx are compiled game models. They can be either characters or props, and are created by compiling the .smd and the .qc files. Compiled models should be saved within the game models folder. You may need to run through some of these key file locations again later, since I know it can be a lot to take in all at once. We'll start off by looking at how we create a basic QC file, the instruction outline we'll use to compile our model. First, in the model source folder, right-click and select a new text file, and we're going to name it bot.qc. Then we'll copy in our sample QC file, which you can find in the extras folder of your 201 database. One very important thing to note here, even though it looks like we have a QC file, in reality, if we go to our folder options, View, and unclick the Hide extension for known file types, hit Apply, we can see that the file is not actually a .qc file, it's a .qc.txt. And our compiler won't recognize it for what it is, and it won't work. It needs to be just a .qc file. This is very important because without this, we won't be able to compile the model. To open QC files correctly, right-click, select Open With, choose Program, and choose Notepad. Click the box that says it will always open using Notepad. And now let's paste in the contents of the sample QC file. Save it, close. It might tell you that there isn't a TXT extension, but just save it, and we can double click to open it up, and you can see that the QC information is in there. Good. Now let's take a look at some of the specific areas within the QC file. The first part is the comments section. Here you place the name of the model, the material it uses, and or a brief description. Next, in $model name, it tells us the name of the file or model that we're going to create. In this case, it will create a folder in the humans, group 03, and then in the group 3, it will save a compiled model as male05.mdl. The $CD material is simply the folder where you can find the materials for that model. We don't tell it which material, just the folder. In the folder, you will find the .vmt file that we're going to create. The next group of lines that begins with the start I face data and ends with end I face data is simply the position controls of the eyes and some of the other attachments that it has. In this case, we have the eyes, mouth, position of the chest. Let's concentrate on this line here that says $model. First, you'll see male05, the name we are assigning the model, so that we can recognize it within the game. And next to it, a line referencing the model.smd that will export from Softimage. Include with body rules is referencing a default file that controls the hierarchy of our model. For now, we're going to keep using the standard defaults. Surface prop applies a surface property to the entire model. It affects the physical parameters, like what noise it makes when it crashes, what kind of particles it emits when you shoot it. Here's a list of examples of the types of properties you can apply. You'll see that we have plenty of different options to choose from. Types of rocks, liquids, metals, glass, paper, plastic, types of skin, snow, terrain, and wood. Within the SDK, you'll find a complete listing of the different materials available for you to apply. The B box is a box that surrounds the character and detects collisions. These lines reference how the hierarchy of the model will act. Since we are first going to be simply replacing standard models from Half-Life, we'll leave these parameters as the defaults. And since we're going to be using the default Half-Life rig, we'll leave these commands as they are as well. Include model will include a model that is already compiled in the compiling of the new model. This includes movement and animations, postures, everything that we want to include in the animation of our model. Finally, we have the hitbox and the ragdoll. The hitbox is important because the file determines the point where the model can be impacted and where it can be harmed or shot. And ragdoll is how the model will react when it receives a certain amount of damage and finally when it dies. For us to get started compiling our models, we'll pay attention to these three key lines, and for now we'll ignore everything else. These basic three lines are all we need to place characters into Half-Life 2. So supposing our model is going to be named Bot, let's make a few adjustments. We can change all this to models, bot, bot.mdl. Materials will save in models, bot. The name of the model is bot. And the file that we'll be referencing is one that we'll export later on from XSI. Let's call it bot.smd. Now that we have changed those three lines, we can move on to XSI and get ready to place the replacement characters into our game. Let's quickly go over how to install the Valve plugin in XSI. Go to your hard disk and navigate to Program Files, Steam, Steam Apps, your username, Source SDK, XSI. Here you'll find the XSI add-on that we're going to install. Open Softimage and then drag the .add-on anywhere into the main interface. Now, up at the top, within the File menu, it shows the plugin tools. Export SMD, Import SMD, VMF, which is for maps, Weight Map Import and Export, Characters, we have the Biped Guide and the Biped Rig from Guide, and that's basically all there is to it. We'll talk about how to use those in a little bit. Let's talk about textures. We'll work with the textures as TGA files. From those, we will create VTF files. The pixel dimensions we need to work in are in multiples of 2 starting with 16. 16 by 16, 32 by 32, 64 by 64, 128 by 128, etc. All the way up to 2048 by 2048. We can also create combinations, like 256 by 512, 256 by 256, or 512 by 256. Down here, we can start to see the differences in sizes. 128 by 128, 256 by 256, and the 256 by 512. The recommended size for textures is 256 by 256, but of course this really depends on the size of the object that we are texturing or creating. The size of the texture will depend on what model we are using, what kind of detail we want in that model, and how close the camera will actually be to it. Appropriate dimensions for a character can be 256 by 256 or 512 by 256. Working at 1024 by 2048 is going to create a much larger graphic, but also allows for a lot more detail and contrast in the image. So for now, that's the resolution that we're going to work with. TGA files contain three primary colors, which are red, green, and blue, as well as an alpha or opacity channel. When you save your TGA files, be sure that you save them at 32 bits if you want to retain the transparency in the image. Then, we'll use the SDK to compile our textures to the VTF format, which can be used by the game engine. In Photoshop, let's open our soon-to-be texture. You can find it in the database 201 under Pictures, called Agavella Facemap. First, we want to remember to check the dimensions of the texture, which we were just discussing. 512 by 256. Perfect. And right now, since we're working with a PSD, we're going to need to save the file as a TGA. When we do, it gives us the option to save in either 24 or 32 bits. Since we don't have any alpha or transparency in the image, saving it at 24 bits is sufficient. Now we'll actually compile some textures. We'll start with Agavella here, and then we'll go back and learn to create one on our own. Open up Windows Explorer, and navigate back to the Pictures folder within the 201 database. I apologize if my Windows Explorer looks a bit odd. I'm currently using a tabbed version, which can make things a bit easier, but it should be all the same. Once inside the Pictures folder, copy the Agavella TGA, and then navigate down to Steam Apps, your username, Half-Life 2 Deathmatch, HL2MP, and we'll paste it into the materials source folder which we created earlier. There it is. Now that we have the TGA in the materials source folder, go back to your Explorer, and navigate to your local drive, Program Files, Steam, Steam Apps, Noesis 3D, or your username, Source SDK, and Bin. Here, we're looking for the vtex.exe utility program. Open up another window so you can see both locations. In this window, I have my facemap TGA, and what we're going to do is drag our TGA file to the vtex.exe program. It may take a few moments, but you should see a screen displaying the results of the compile. Once that's there, go ahead and close it, and then look in the Materials folder to see the VTF file we have just generated. Next, we'll create the face of the character using our own photograph. To do this, we must take a series of photographs. We'll start with the left profile, then one at 45 degrees, a front view, 45 degrees to the right profile, and a back view. Once we have our 6 photographs, we're going to join them in Photoshop and create a face map. This is an example result of the unfolded texture. Here we can see the photograph from the front, the bit from the 45, the profile, and the back. Once the face map is created, go to the Database 201 Extras folder for some reference images. In Photoshop, we will try to match our image to one of these reference pictures. When we're finished, we'll follow the path and save it to the Mail Group 03 directory. So to help us choose which existing Half-Life 2 character will be the best match for our new face, open the Database 201 Extras folder, and in Players, we have the facemap template, which should help us choose the best match. In each layer, there are different faces. These are the different default characters that come in the game. We'll use these as templates to match our own photograph and get everything lined up as best as possible. What we want to do is look for one of the pictures that is most laid out like our own, especially in regards to the proportion of the eyes, the nose, and mouth. You may have to test out a few different ones to see which is the most like your own photograph. First, take your photograph and place the layer. You may have to scale it down a bit. Control T in Photoshop to scale. And I try to keep it more or less as proportional as possible. Now, move your image down to the bottom and turn off all but the first outline. Let's see. Looking at the template may be a little tough to match everything up. We can change the blending mode of our outlines to see through the white and make things a bit easier. See if it's any better. Try the next one. Change to linear burn to see the outline superimposed over our image. And this one matches pretty well. Go to the next one. Change to linear burn to see the outline superimposed over our image. And this one could work for the Agavilla here. Since we're going to be using a model that has already been made in the library, we'll have to try to match our image to the reference. It may not be exact. The only way it can be exact is if we actually replace the model in 3D, which we'll get to a bit later. Now we're going to try to match up the mouth, the nose, and the eyes. Try to get them as close as you can, something like that. It's very important to know the name of the texture we're going to use. In this case, we're using Ted's layout. Be sure to remember which one you're using, as we'll need Ted again in a second. Once the texture is properly aligned, we'll remind ourselves where we're going to save it. So in this case, since we're in Deathmatch multiplayer, we're going to save it under HL2MP, Materials, Models, Humans, then depending on if you're using a male or female, select that, Group 03, and the name of the player, _facemap, VTF. Right, that's going to be our finished VTF, but to create that VTF, we'll need to save the TGA we just made and then compile it into the VTF format. So go back to Photoshop and save our TGA as Ted_facemap. Turn off the reference grid. And if you look at the texture, you will see it doesn't have eyes. The eyes are actually applied to the model itself. It can be a bit spooky to look at the texture, but he's going to be just fine. File, Save As, choose TGA, navigate to C, Program Files, Steam, Steam Apps, Noesis 3D, or your username, Source SDK Content, HL2MP, Material Source, and here we need to use the character's name. So in our case it's Ted. Ted_facemap.tga. And we use 24-bit image because we don't have an alpha channel. Now we're ready to compile. Open the Explorer, locate the file that we just saved, under C, Program Files, Steam, Steam Apps, username, source SDK content, HL2MP, material source, and we're going to drag it to the vtext.exe. And that's it. We're done. It's compiled to the Half-Life 2 Deathmatch HL2MP materials folder. There it is. Now we'll remind ourselves again where we need to put it. In the HL2MP materials models human male group 03. If that directory doesn't exist yet on your computer, go ahead and create it now. Models, make new folder, humans, male, group 03. Paste. And there he is. And we got him there. Now we're going to create our own personalized icon for our guy using an existing template. For now, we'll create the icon using a photograph, but later on, if we want to be more creative, we can take a screenshot from inside the game and use that instead. In the DVD extras, under Players, open the thumbnail template. This is just an image that we've prepared with the specific dimensions for character icons. If the guidelines appear in Photoshop, you can go to View and turn off Extras to make them appear or disappear. Now take the front photograph, scale it to an appropriate size, however you would like it to look. Then we can simply select whatever falls outside the guides and delete it. We could also use the alpha channel to create a mask and leave the background transparent. I've got an example of that in here, set up like the police characters in the game. Now that we have the image prepped, let's see where to save it. Let's save it in HL2MP, Materials, and VGUI, which is the user interface, Player Models, Humans, Group 03. And this is important as well. If we use the Van facemap, we're going to save it as male 01. If we use Ted, we're going to call it male 02. Joe would be male 03, and the same down the line, including all the girls. If we use Cho, we would use female 01, Joey's female 02, and so on. So since we use Ted, we're going to save as male 02. Switch to our template, and we're going to call it, since it's Ted, male _02. File, save as, C, program files, Steam, Steam apps, your username, source SDK content, HL2MP, materials source. And here, select to save it as a TGA. And again, instead of naming it Ted, now we name it male _02. Good. Now we're ready to compile it as our icon. Go to Source SDK Content, HL2MP, Material Source, and we compile the male 02 by dragging it to the vtext.exe program. If you take a look in the Half-Life 2 Deathmatch, HL2MP Materials folder, it should be there. Male 02. Now you can double check where to move it. We'll cut it from the Materials folder and go into VGUI, Player Models, Humans, Group 03, and paste. Excellent. Now we can test it by starting up a deathmatch game. Alright, so inside an actual deathmatch game, select Male 2, which is the character texture we've replaced. And you'll see the new icon that we've created. And once we're in, and obviously, since we're playing a first-person shooter, we can't immediately actually see our new face. What we actually have to do is kill ourselves so that we get a third-person view. We'll just find a good place to do it. Select a grenade. Turn towards the wall. Boom. Okay, so it's a bit odd, but by moving the mouse around you can see the texture looks to be applied correctly. Let's try one more time. This time with the gravity gun. We'll launch something straight up. And... cool. There's a new guy. He's just not looking very happy. Okay, this time I actually have another player joined on the server who has selected Male 02 as his character. If we run up to him, we can walk around and make sure everything seems to be lined up alright. A lot easier way of doing it. Once I'm content, I'll just let him know by grabbing a nice explosive barrel and letting him have it. Boom. Alright, now we'll walk around, check out the body. Cool. Remember that any changes you make in the folders for Half-Life 2, Deathmatch, HL2MP are going to be local to your computer. Your computer has your face, but if those files don't exist on another player's computer, they won't see the same characters as you do. They'll just see the defaults. If you want to share your face with friends, you must copy the textures onto the other player's computer, as well as any other players connected to the network. It doesn't matter if you're using a local network or the internet. If you're working on a shared local network, I recommend that you place all your models and materials, in this case the newly created face maps, somewhere on the network. From that folder, each player can copy those materials individually onto their computer, and that way everyone will have the same materials and see everyone's custom faces. The folder that you're going to need to copy around is the user Half-Life 2 Deathmatch HL2MP materials folder. XSI gives us a lot of really useful tools to help create some great characters. We're going to start by looking at one of them in particular. Under Model, go to Primitive, Model, and let's get a body man. This model can help us as a proportional reference, or we can actually use it as a starting point to build from. Let's see what we can do with him. We use him as a scale reference for his extremities. Of course, we can embellish on certain areas or tweak him however we want, but as a basic biped, he's just a great jump-off point. If you press 8 to explore, you'll notice the UV clusters have already been assigned. This will help us a lot in the next chapters as we practice texture painting. We'll begin by applying a texture. Switch to the Render tab and choose Get, Texture, Image, New from File, Go to Database 201, select Pictures, and choose the black.psd texture. This will give us a nice blank slate to experiment with. Choose the explicit UV projection, then press Alt-7 to bring up the texture editor, and take a look at the unfolded UVs, which should make it easy for us to paint and edit. You probably already noticed the symmetrical face portion of the texture, but the rest may not be so obvious. Let's try to identify the different parts of the model. To do this, go to View and turn off the polygon bisectors, which are the little crosses. And we're also going to turn off the overlaps. You can also turn these on or off with buttons just under the View menu. Next, we'll create a stamp or a snapshot of our UVs and try some basic painting in Photoshop. Go to Edit and select Stamp Mesh. Change the file name from PIC to PSD. Name it Texture. And click OK to save it. It'll ask you if you want to update the image exercise referencing to the one that we just saved. Select Yes. Now I'm going to open Photoshop. File, Open. Select the texture.psd we just saved. And here we have our stamp image with the unfolded UVs. Next, we want to separate the outlines so we have a clean area to work with. Use the magic wand to select the black, zero tolerance, and without contiguous. Go to Select, Invert, Copy, Control-C to copy, make a new layer. Go to the new layer, turn this one off, and Control-V to paste. Now create a new layer, put it under the other layer, and fill it in. We're doing this so that we have a grid as a reference, but we'll be able to paint underneath on the black. Alright, we're going to paint on top of this layer, and I'm going to start with some basic colors. Let's just choose a generic kind of flesh tone. We're not really going to worry about any detail right now, just adding the color. Let's add some blue and paint in these. Some green. Orange. Maybe one more. Just paint some dark ones. That's good. And that's it. Now, I'm going to save the texture, go back to XSI, and you can see that the texture has been updated. So you can go back, turn off the reference grid, save it again, and there we have our texture. You'll see that the orange areas we painted are the pants, the green is the chest and the back, We have the head and the hands. If we go back and paint some more, we can identify some more key areas that we may still be missing. For example, let's just paint some more detail in the face. Go back to Photoshop, turn on our reference. And let's say we want some eyebrows. Just paint in something like that. We can paint a little more color in the lips. A little here. A little bit more. Just something neutral. We can play a little bit with the character's hair. It's a lot more efficient if we create different layers for each of the different bits, the hair, the skin, etc. But we're not going to spend too much time on this right now. I just want you to see how it works. Get a basic idea. There's a lot of techniques to painting good textures. But right now I'm just going to give you a real basic overview. Alright, so I'm already trying to add too much detail. Let's just save it. Go back and get a better idea. You could spend a while really detailing the different areas of even the simplest model. But you can also get some great results really quickly if you're a bit creative. Okay, let's modify our guy's geometry a bit using excess size symmetry functionality. I can start to move points with the tweak tool, or by pressing M on the keyboard. Turn on symmetry. And then, by selecting various points, we can start to reshape our model. The great thing about using symmetry is that every adjustment I make, XSI replicates symmetrically in perfect proportion. This technique, when paired with the proportional option, can let us very quickly begin creating interesting characters. Press R to adjust your proportional radius. Let's make the head a little bit more exaggerated. Pull out the nose. Maybe even a little bit more. I'll give him some big arms just to bulk him up a little bit. And slowly we can just kind of sculpt out our new character. A bit like you would with clay, adding a little bit, removing bits. Smoothing out some areas. Anything to give him some more personality. Pull out the ears. Maybe give his head a more distinctive shape. Okay. Well, that's just sort of a start. You can definitely use this technique to create an entire clan of some pretty out there creatures. I'm kind of imagining some alien map world populated with all kinds of crazy looking guys. And if we spend a little time painting textures, we could get a really scary looking crew. A good thing to note while working with symmetry is that if you duplicate on one side, Control D to duplicate, turn off proportional, it doesn't duplicate symmetrically. So undo. If we want our character to be perfectly symmetrical, let's go to our front view, and using Y, select half of the character, erase, and we'll work with just one half, which can also help conserve some system resources. Reselect our polygon by pressing U, then right-click, and choose Extrude Along Axis. Add a few subdivisions under the Extrude tab, Subdivisions, adjust the inset a bit, then go to the Transform tab and rotate. And maybe scale it a bit longer. This way, if we're trying to give him some horns or something, we can keep tweaking, and we don't have to worry about them not matching up in the end. Now switch to your shaded view. And let's take a closer look at the geometry that we've created. Switch to the Model tab, select the Add Edge tool, and let's add just a touch or two of detail to round them out a bit. You can add as much as you'd like. Once you're done, choose Polygon Mesh, Symmetrize Polygons. You can adjust the offset and distance if needs be. And when you switch back to a textured view, notice the texture has also been preserved. Select the model, hit Alt-7, and we return to editing our UVs. Excellent. Alright, let's erase him. And just like we got a body man, we can choose a body woman. She's very similar, although obviously a better starting point for any female characters you may want to develop. And inside the texture editor, you'll see that the UVs are unfolded in just the same way. Now let's get another primitive model called Faceman. I'm going to leave the property editor window off to the side and set a lock. Then by pressing A, I can zoom in and we have a basic head. Notice that the property editor is broken down into several sections. Head forehead has some basic size and shape parameters. The lower head has sliders for cheeks, the jaw, chin, neck, as well as other tabs for eyes, nose, mouth, and ears. These sliders are really useful for making quick and simple adjustments that allow you to custom tailor your character's face. Pull out his forehead a little bit, beef up his neck, make the jaw a little bigger, adjust his nose, tweak the mouth. We can position it higher or lower. In the top, lower lip, the ears, you can really have a lot of fun just dragging sliders and creating heads. We can add some detail to our face's polygon mesh by selecting it and pressing the plus or minus key on the numeric pad, which adds or removes subdivisions. This is simply subdividing the geometry to make it a little smoother. You can do it again, and it gets even smoother. And you can even save your presets. For example, if you decide you like this one, go to the Render panel, and under Render Region, Region Tool, or by simply pressing Q on your keyboard, select a region to render. Wait a second. And now click Save to save your preset using the render region as a thumbnail. Navigate to the Tool and Database, create a presets folder if you don't already have one, and save it. Cool. Let's try one more face. Just something different from the last guy. Maybe we'll make him a bit gaunt, suck in the cheeks. Really bring in the neck. His ears. Bring him in a bit. But I want to make him a little bit bigger. And then open them up a bit. Alright, I'm just tweaking. Something like that. Alright, and let's save these settings as another preset. Render region. Save. If I select icons, you'll see the first preset in there. And now, if I choose load, I can retrieve the first preset. But the window's closed, so where can we find it again? Open Explorer. Go to Man Face. We have Face 1 with an icon that represents the custom property editor. We click on the C. We get our Properties window. And we can continue to make any adjustments we have in mind. And of course, by pressing Alt-7, we can unfold its UVs so that we can custom paint its texture. Alright, now let's look how to give it some bones and chains. A chain is a group of bones. In the Model tab, under Create, Skeleton, we have 2D chains and 3D chains. The difference is the limit of the bone's rotation. 2D chains are restricted to certain axes, and the 3D chains can move freely. A typical example of a 3D chain is the tail of a dog. It can move freely on any axis. But we're going to concentrate on 2D chains, which most resemble the human bone structure. We'll practice drawing a few bones and chains, and then actually use them to affect some geometry. So let's start by selecting a 2D chain. Once you click, you get a pen to begin drawing. So click on the screen to start. Another click further along and it draws the bone. The bone will stay put as soon as you release the mouse, and then you have the option to end the chain using the middle or right mouse button if you want a chain with only one bone, or continue drawing more bones using the left mouse button. Let's start with a 2-bone chain like I have here. then right-click to end the tool. And I'm going to maximize the front view in vertical. And I'm going to replace the right view with our schematic view. Select View, Rearrange All, and we have the root, which will move the whole system. We have the first bone, the second bone, and the effector. The effector lets me manipulate the chain of bones the way I'm showing here, each bone applying specific forces on the others it's connected to. If we want to modify the position of the bone, we can go to Skeleton and choose Move Joint or Branch, or by pressing Ctrl J. Using this tool, I can click and move the position of the bones. Now let's talk about forward kinematic motion versus inverse kinematic motion. Select the effector at the end of the chain, and in this case, the effector is used for inverse kinematics. If I move the effector, the bones will try to follow a natural movement, trying to simulate how bones would actually move in a human body. This is called inverse kinematics. But, for example, take the bone and rotate it like this at what we could call the knee, and I'm now working with forward kinematics. This is forward kinematics, and this is inverse kinematics. When we are animating a character, we normally use forward kinematics for the parts of the upper body, the arms, the torso, the head, and we use inverse kinematics for the legs. Before we set up the more advanced rigs, let's start by creating our own very simple one. It is also important to realize that the view in which we decide to draw our bones is a very significant thing. It actually is going to dictate the angle in which our bones will move. So the view you're drawing in is a good thing to take into account before you get too deep. Normally, we have our top, front, and right. Okay. I'm going to erase this bone chain. And now let's get a sphere, for example, which we'll use to simulate the human body. Then we'll give it some legs. Because of how we see our character, we usually begin to work from the front view. If I draw a chain in the front view, however, we'll get some strange joint movement in the legs. Therefore, I'm going to draw the chain in the right view. Something more or less like that. Ctrl J to modify. And V to move. Now we have an option under Skeleton, Duplicate Symmetry, choose Default, and it automatically places both of them. Now we're going to take both the root bones, go to the schematic view, root, parent, and you have to select the parent. In this case, if you look down below, you'll notice that the middle mouse button will pick our parent. And the sphere becomes the parent of the two legs. Now, if I move the sphere, the legs will follow. and we can play with our effectors to simulate some walking movements. Next, let's look at what we call constraints. Go to Primitive, Implicit, and in this case, let's select a cube. Implicits work well as they're easy to see and manipulate, but will not render. So scale it down a bit, and I'm going to place it more or less in the same position as the effector. Duplicate, and then move the other one a little bit for the other leg. And now we're going to constrain the position of the effector on the cube. Go to Constrain, Position, and select the implicit cube. Same with this one. Constrain, Position, and select the cube. Now, if I move the character's body, it responds with legs that are anchored to the floor. If I want it to walk, I have to move the cube itself. This is actually a really great exercise in a very basic rig. In more advanced rigs, there are many parent relationships between objects and constraints. I'm going to move it back to its original position. There we are. Now, you can always rotate or reposition your bones later, but if I wanted to add arms to my rig here, it would be best to begin drawing them in the top view, like this, so they bend in front of the body as real arms would. Then we position them, parent them, and then we can finesse. Select the whole chain, go to Skeleton, Duplicate Symmetry, OK, and there we go. But we still have to parent up this arm. So click Parent, then middle click to pick, and now you have it. You can see how even the simplest rig can lend a lot of life to a character. XSI contains some very useful pre-built rigs and advanced rigging tools which allow an enormous amount of control over your characters. You may want to zoom in a little. I can move and animate the effectors using inverse kinematics, or I can animate the bones locally to work with forward kinematics. Now press Ctrl-N for New Scene. And let's look at the pre-built rigs in XSI. We'll start with a simple one. Skeleton Man Basic. It may look complex, But this is actually a very simple rig as well. It's just separated into various parts. You have some constraints, or you can move certain bones to adjust down the hierarchy. You have some constraints, one of the advantages of the pre-made rigs is that if I choose the body man, it is, by default, in scale to the rig, which we could quickly use to position or modify the character. It's the same with the body woman. The second XSI rig we're going to look at is a Skeleton Man Complete. This one has several more controls and a more detailed bone structure. Including bones in the hands. It also has these little cubes behind it that control the rotation of the elbows. Undo. And you'll notice that the face has some nulls that would really help us with any facial animation that we do. This bone for the jaw. If I pull out the body man again and switch to shaded, you may notice the crosses that mark the areas that have been used to capture the face so that we can animate it. Down below, you can try moving around the little cubes. Switch back to wireframe, and you'll see how they actually help rotate the knees. We also have Biped Box, Biped Skeleton, and Biped Rig. Biped Box simply generates boxes at each key area of the body. The Biped Box can be useful, though, when you're setting up basic forms. In the next chapter, we'll talk about some of the more advanced motion rigs. It may help out to pause for a minute or two and just kind of experiment for yourself with some of the rigs we've been talking about. Okay, from the Model tab, select Primitive, Model, Biped Rig. This is a more advanced rig, much closer to what we'll actually be using most of the time. I'm going to take away the body. This rig is definitely a bit more elaborate. It already has constraints applied. And it also has controls for the knees, arms, elbows. You can see the series of bones that simulate the vertebrae. And if I rotate this inner control, you'll see it rotate the hips and spine quite convincingly. Using just that, we can make our guy do a nice little dance. We have controls on the shoulders, the head, like is it some kind of heavy metal show. And even with the control near the heel, the pivot of his feet. Also, a really great feature is that if I select a part of the rig and press F3, the Synoptic Editor appears. This contains several different presets for that rig. You might want to mess around with them for a bit. We can reset all to go back to the original position. It has different, in this case, positions or poses for the hands. You can see them here. Relaxed, a fist, spread. There are even sliders where we can control all the parts independently. The fingers, right and left hands, even rotating parts of the bones. I can select this outer control here and move up or down, or we can grab the leg constraints and experiment. There are also a bunch of different preset poses that you can use as starting points, or to animate between. Take a couple minutes and just check out how some of these poses are put together. Get a feel for the rig. Cool. Now let's look at how we can use these bones to actually deform models. Let's get a sphere. Maximize the window. Go to Skeleton, 2D Chain, and draw a 2-bone chain from the base to the middle, and then up to the top. Now what we want is for the bones to deform the sphere when you manipulate the bones. The way to do that is to designate this as a deforming envelope. To do that, we have to go to the Animation menu, which is number 2, and from here, we choose Envelope in the Deform submenu, and then, making sure the sphere is selected, select Set Envelope. It asks if we want to apply it as a model operator or as an animation operator. Normally, we're going to apply it as an animation operator. So we'll press Yes, and it asks us to choose the bones. Left-click to individually select Bone 1 and Bone 2, then press the right mouse button to end your pick session. Now the first thing you'll notice is that it assigns blue to this bone and yellow to this bone, and that it assigns points with those colors, and it assigns points with those colors depending on where the points are in position to the bones. Go to your shaded view and press W to begin using the Weight Brush Paint tool. We can see the colors of the bones and the gradient that exists between the two bones, or the blue and the yellow, blending them into each other. If I take the effector and move it, I can deform the sphere like so. I can use the effector, or I can choose and rotate each separate bone. Next, we're going to go into some detail on how to control the influence each bone has on its surroundings. While enveloping, we can assign greater weights to specific bones, even though it's not immediately adjacent. With the object selected, let's select your Weight Brush Paint panel by clicking the small brush near the bottom left corner of your screen. Up here, we have a listing of bones and their corresponding colors. Now I'm going to tell my brush to paint influence from the yellow bone. W to paint. And let's make sure our tool is in Add, not Smooth mode. Okay. Now with the middle mouse button, I can expand my brush size and I can paint in more yellow influence. Now, when I move the object, I have more influence from the yellow bone. Again, W, and I can continue right on painting, giving more influence to the top bone. I can also select a group of points and tell it that all these points should be assigned to the blue bone. I just hit Local Reassign, and then I can choose the blue bone. Now, even if I move this, I can rotate it. Only one part is being affected. Then I can do it to the whole model. Local Reassign, and there we are. If I rotate this one, it doesn't have any effect on the points. And if I rotate this one, it affects the complete sphere. For even more control, let's check out the weight editor by choosing the option here. It shows me the influence in percentage values. Here we have the points, 57 points, and it shows me the percentage of influence the blue bone has in comparison with the other bones. In this case, we have 100% of the points being influenced by the blue bone. If I go and select the top portion, Local Reassign to the yellow bone, and open the weight editor again, I can see how these percentages have changed. 0, 100, 0, 100, 0, 100, 0, 100. Now what I'm going to do is apply a smooth distribution to these influences. Go to the weight map, and right now the two weights are pretty much evenly matched. So let's tell it to apply a smooth transition so that we can even it out a bit. Apply smooth, and you can see how the points change their percentages. Now, if I adjust the neighborhood depth and the distance scaling, I get a much smoother gradient. While you're weight painting, keep in mind that you always have 100% influence to distribute somewhere. It's just a matter of how you choose to distribute that influence that creates believable deformations. You can even export this weight map as a preset, load presets, save other presets, and apply them to different characters. Next, we're going to attempt a little more lifelike envelope. In a new scene, get a primitive, model, Faceman. and then choose either of the two presets you created earlier. Switch to shaded, and subdivide it a couple times using the plus key on your keyboard. And we have our character head. Now, let's apply a bone to what would be his neck, one for his head, and one for his jaw. Go to Skeleton, 2D Chain, and you'll notice right away that the bone is too big. So let's scale up our head a bit, and it's going to be a lot easier. About 3.5 times. Skeleton, 2D Chain, place it where the neck would be. We'll stop there. And draw another one for the head. Right button to end. And a jawbone from just under the ear out toward the chin. Now, let's create the hierarchy before we start deforming the model. We'll create our hierarchy using the bones we just created inside our head, in which the parent bones will propagate their position and rotation values to the child bones. Open the schematic by pressing 9. And we're going to make the head bone a child of the neck bone. Middle-click the root of the head bone to select the hierarchy, hit Parent, and then middle-click the effector of the neck bone. Now let's make the jaw a child of the head bone by middle-clicking the root of the jaw hierarchy, selecting Parent, and then middle-clicking the head bone effector. Okay, so now if I move the neck bone, the whole chain will follow. If I rotate what would be the head, the jaw follows. So next we're going to create a group of bones that will serve as our deformers. Select the bones, Control G, and then press F2 to give it a new name. Let's call it envelope group. That way we have isolated the 3 bones that we're going to use. Now by selecting the entire object, we go to Deform, Envelope, Set Envelope. Do you want to create an animation operator? Yes. And select the envelope group. Notice the combination of colors. Pink for the neck, blue for the head, and yellow for the jaw. But here, for example, if I rotate the yellow bone, it rotates a little too high. We can easily fix this. So let's tell it that all these points, including these ones, all these up top and in the back, we want to assign to the blue bone. Select the weight brush, go to Local Reassign, and select the head bone. Now let's try it. I want to constrain the eyes in a few points here. all these guys to the head bone as well. These other points don't really matter too much. And now let's zoom and select some of the points we want to move with the jaw. Let's go to Local Reassign to the yellow bone, the jaw. Now if I rotate, you'll notice that we still have some small problems that we're going to need to fix. So identify any of the problem points. In this case, it looks like these here. Local Reassign to here. And we'll do the opposite above. We can also make it so that when the jaw moves, some points on the cheeks move as well. Select the yellow bone, press W, select Add, and we'll paint a little. We'll add a little opacity. Then use R to make your brush a bit smaller. Activate the symmetry function to keep things even. And paint. We just want to add a little influence in the blue. And remove a little bit on the eyes. Now let's check it out. We can pull a little bit up. Five opacity. A little bit smaller. And a little bit more influence for the yellow bone. I'm going to add back a little blue here. And smooth it over. Now, if I rotate the head bone, we'll turn his head from side to side, or up and down. And if I rotate the jawbone, we'll open and close his mouth. But I really don't want his neck to move so much with the mouth. So let's paint a bit more influence here in the pink. Add, up the opacity. And you can just watch the reaction in your mesh as you paint. You can see the geometry change as I adjust the amount of influence each bone has over the envelope mesh. Again, this is an area that we could spend a lot of time finessing our work, but we've already achieved some pretty nice results. Now let's try enveloping a complete character. In a new scene, get a body woman. Then select the biped rig, and don't worry if it looks a bit daunting. Select the body. Make sure you're in the animation tool set. Select envelope, set envelope, apply it with an animation operator, yes, and now we have a pick arrow. So to make picking easier, press 8 to bring up the Explorer, open the biped rig components, click the group called envelope group. Then press your right button to end the pick session, and it's assigned. Switch to shaded view, and move some of the controls to see how the rig is deforming our model. You may notice when rotating the arms, there's still a few areas we'll want to work on. You could also look for any other areas that may be problematic. It's mostly under the arms. In general, though, it works pretty well. So we should be able to clean up these areas without much trouble. Switch to your weight map brush by pressing W. Switch to your weight map by pressing the little brush. And let's apply a smooth. Bring up the neighborhood depth a bit to spread the influence. And let's hit F3 to bring up the synoptic editor and test some poses. Just try out a few different poses to see how the envelope is working. With the mesh selected, add a few subdivisions using the plus key to make it a little bit smoother. And try moving her around a bit. Good, well, that's not too hard. But let's see how to deal with models not already in perfect proportion with our rigs. Select File, Open, navigate to Scenes, and open the Small Guy scene. No, we don't want to save the previous scene. Okay. So here's an interesting looking little guy. Obviously, not all the models we're going to work with are going to have human forms or the same human proportions. So if we select, for example, exercise standard body man, they have completely different proportions. And if we select the biped rig, it's going to have the wrong positions assigned. So let's switch to wireframe. Drag to select the rig, or better yet, let's press 8 to use the Explorer, and get rid of the biped rig so we're just left with our small guy. And check out a useful tool under Create Character called Biped Guide. And click OK. Now we can just adjust this guide to match, starting with what would be the waist of our character. To make it easier, select the mesh, hit the selection button, visibility, and uncheck the selectability of the character. Hit the lock, 2 clicks, and we'll leave it there. And now we can see a bit better to line our hips. Then bring down the knees. You'll notice that we're adjusting symmetrically. Bringing up the feet. Switch to a user view, new perspective. Make the feet a bit smaller. And rotate them out a little, matching as best as we can. Now let's go to the upper body, the neck, the head, bringing the shoulders in a bit, the elbows, the hands. And it's a good idea to check out our different views to be more precise. Make sure everything is properly aligned. The better our guide placement is now, the better our final results are going to be. So I'll just move this a bit more, right around there. And let's not forget our reference points. These little guys tell a rig how to better weight the mesh, especially in areas such as the stomach here, and for bits like the calves, which are further away from the bones. Just pull the controls in for a nice tight fit. The more information we have for our geometry, the better it's going to look in the end. So bring in the spacing besides the arms. The ears. Pull these down a little. Lift this up. Like that. Now take another quick look to ensure everything looks in place. And now that we have placed the guide in the appropriate form and position, let's go to Character, Rig from Biped Guide. And you'll notice that we have different options here for the head, the stomach, how they'll act. For now, we're just going to leave all the defaults and hit OK. It takes a few seconds to create and apply the rig from the guide. And there we have it. Now if we want to explore, character, selection, visibility, we'll reactivate the selectability. And we can erase our guide by middle-clicking to select the entire branch and then hitting delete. Then go to envelope, select envelope as an animation operator, yes. Look for our biped, click envelope group, and right-click to end. Switch to shaded view. No, let's see, how about a hidden line mode? And right away, we can see a problem in the knees, just bending a bit too close together. So let's move these effectors back here, each in a little. And remember that all these deformations are created with the weight maps. So in any of these problem areas, we'll select a weight brush, apply a smooth, lock the window and leave it over here. And we're going to want to fix under the arms, bringing up the neighborhood depth just a few steps. Test out some other areas and see how it's moving. And it looks like there are just a few other areas we could probably smooth out a little bit more. So let's bring the neighborhood depth up even more to relax the movement a bit. Check weights in the elbows. We can always paint influence into parts that we don't like, but really, this has done a pretty good job in its placement. I mean, the stomach here is almost perfect. Press W for the weight brush. Turn off proportional and symmetry. Go to pick, wireframe, and we can assign all these points to this bone. It's running a little bit slow because I'm capturing as I go. Normally it's going to move a lot faster. Now let's start painting. Apply a quick smooth. When you first get started on your characters, I recommend that you start with a character that has a lot fewer polygons. That way the process is going to be much faster, both for the computer and the amount of weight mapping that you'll need. In the Valve Source Utilities menu, under Characters, we have the Valve Biped Guide. It's very similar to the guide we have just used, except that this one focuses on the skeleton of characters you will use in Valve games. Now that I have a guide, go to Valve Source, Characters, and create rig from guide. The process may take a while, and it's going to open a lot of windows. Once it's done, go ahead and close all those windows. We can middle click to select and erase the guide. What is left is a rig similar to the one we were already using. The controls for the spine are these little spheres. The same with the head, the neck to the head, the shoulders, the hands move with inverse kinematics, the elbows, and the same for the knees. Very similar to our last rig. Now let's apply it to a character. Now that we have the rig made, let's import a character. Press 5 to open the browser. Go to db201, Models, and we have the nsc.emdl. You'll notice that the character is scaled much smaller than the rig. This is because the Half-Life 2 characters use a specific larger scale. To scale our guy up to match, press 8 to bring up the Explorer, S for Scene, and then F to Find. Then we're going to cut the model and erase the parent, X on your keyboard to scale, and we're going to scale our character uniformly from the center to just about match the proportions of the Valve rig. Switch to the front view, press G to turn off the background grid, and look for a scale that matches the rig. It may help to switch to a user view and spin around, checking areas like the hands to ensure that they're lining up. Go back to your camera view. Switch to shaded. And it seems to fit pretty good. Okay, next you'll notice that in the transform panel, the values for scale under X, Y, and Z axis are 4.39. So that our scale will work correctly, we need to scale the model and choose Transform Freeze All Transformations. If we don't, we're going to end up with a skewed character within our game. So before we compile, be sure that you've frozen all transformations and that your scale is listed at 1, 1, 1. Okay. Choose Model, New Model, and what this does is take our existing mesh of our character model and makes it a child of the new model object. So when we export using our SMD exporter, the plugin will first look for our new model and then reference the existing mesh underneath. Now we just have to apply the envelope. So select the object, go to Animate, Envelope, Set Envelope, select Yes, press 8 to bring up the Explorer, go to Biped, and middle-click on Envelope Deformers. Right-click to exit, and there we have it. You can try grabbing some different controls and effectors and moving them around a bit to see how its movement is working out. There are a few parts we're going to need to fix or work out a bit more. So again, apply a smooth. And let's start to paint a bit. These parts on the vest have to be reassigned to the bone inside. So go to Pick, and pick that bone inside. W to paint, and just start painting. This way, if I move it, it's going to affect the vertices inside, so they don't move around quite as much. This way, if we move the arm, it won't pull in the chest quite as much. We still want a little movement as the arm rotates, especially up top, but we want to give more influence in the chest and the neck to the bones in the spine. And paint more influence under his arms and out in the chest. We could also spend some time working with the legs, just making sure that each leg isn't pulling too much on the other. Since I've gone ahead and prepared it already, we could also use a presets table to automatically load new weight data for our characters. Select the mesh, press Ctrl E to open the weights editor, go to File, Load Preset, in DB201, and in the Presets folder, we have NSC Weights, which should work out pretty well. I should mention some potential problems. We're almost ready to export, but first we really should check the number of triangles used within our model. You can click on the little eye, Visibility Options, Stats, and check the box to show Selection Info. Now we see our model, and up in the corner it tells us how many triangles it contains. Now we're at about 5,400, and that's an acceptable number, so we can move on and export our model. We'll talk more about the problems too many triangles can cause when we get to our troubleshooting section later on. Now that we have the rig applied to our envelope, we're just about ready to export it and then make any last adjustments before we can actually run around inside the game. First, we just need to make a copy of our texture in the source SDK. So navigate to DB201, pictures, and copy the nsc.tga, and let's place it under Program Files, Steam, Steam Apps, User, Half-Life 2, Deathmatch, HL2MP, Material Source, and just paste your TGA right in there. Now we'll leave it there for a second before we compile. What I'm going to do is copy the entire file path of that folder and then go to the model and assign it that same directory to reference the texture. File, External Files. And there's one here called Pictures nsc.tga. Under User Path, replace the Pictures folder with the file path we copied. Good. Now our texture location is properly referenced. And next, we'll actually export the model. Since we are planning to use the default animation library that ships with Half-Life 2, we'll export our new model to the directory for humans in the SDK. Select the model, go to Valve Source, Export SMD, take a look at the file path, and let's make sure it points to the source SDK content, HL2MP, model source, humans, male, group 03M. And we're going to save it right there. Name it NSC. Make sure that you have Steam running, and we'll export. Let's go ahead and open another window. And navigate back to the SDK content, model source, humans, male, group 3M folder. You'll see our new SMD in there. So next, we'll want to compile the texture. Locate the vtext.exe program in your Steam Apps, username, source SDK, bin folder. And we'll want to drag the TGA texture to the vtext program. It may be easier to create a shortcut for it on the desktop since we're going to be using it more later. And we'll do the same with studiomodel.exe. That's the program we're going to use to compile our model. Now, open up the Half-Life 2 Deathmatch Materials folder. That way we can see our texture appear once we compile. Grab your Photoshop TGA texture and drag it to the vtext.exe. It'll take a few seconds to compile. There you go. We have the compiled texture. Now, we have to generate a material for that texture. So let's make a new folder, call it NSC. And inside, we're going to create a text file called nsc.vmt, which will be our material. A good idea is to assign the VMT files to open with Notepad. That way they'll always open with Notepad, and they'll save you a few steps down the line. Here we have to write a few lines that will describe the type of material and the texture that will be used for our model. In DVD Extras, in the NSC folder, I've already created that material for you. To use it, just copy the text contents and paste it in the material. It's given the illumination type and the texture name. The next step is to create a similar file for the model, not the texture, to reference. We spoke about this file, the QC file, earlier on. It's the same thing. In the extras folder, I provided an NSC QC file. Copy it into your Group03M folder and open it up. In the .qc, you'll find the name of the model up top, the name of the .mdl model file that will be generated, and the name and location of the materials for the model to use. There are also different eye and body controls, and important rules for how our model will act within the game and how it can be affected. Remember, we are still using the pre-made animation library, so pay attention to the HL2MP models folder and drag nsc.qc to the studiomodel.exe program. It should create an NSC folder within the models folder. Inside the NSC folder, you'll see the .mdl, which is our compiled model. So let's right-click and tell it to open with Steam, Steam Apps, User, SDK, Bin, and tell it to open with the model viewer, hlmv.exe. If you double-click it, it will now open in the model viewer and should show our NSC model with the correctly applied textures. Inside the model viewer, you have access to the entire standard Half-Life 2 animation library. With your left mouse button, you can orbit the camera, and with your right mouse button, you can zoom in or out on your model to inspect how everything is working. To show you how important it is that everything is placed in the correct folders, I'm just going to move our material out of its correct folder. Then if I open up the model in the viewer by double-clicking on the model, it comes up with this pink and black texture. This is the default something's wrong material that lets you know that it can't find the correct texture. So it's very important that all your folders be well referenced and in order. Where the model is, where the materials are, and where the texture is. Now that we have everything in order, and we've checked our new model in the model viewer, we're incredibly close to playing inside the game. There are a couple optimization methods we can use, however, to ensure that once we're in the game, our model appears as best it can without overusing system resources. So let's talk about LOD, or level of detail. LOD signifies the level of detail or number of polygons or triangles we will have within a model. Open a scene, go to DB201, Scenes, NSC Rigged. This will allow the engine to process the number of triangles much faster. Now let's stop quickly and adjust our display options to uncheck X-ray mode. There we go. Conforming my model to the placement of the camera should automatically change the number of triangles. For example, right now my model has 5,400 triangles. If I move the model further away, I'm not necessarily going to need as many triangles to keep the detail. So what a level of detail does is allows the engine to process the number of triangles faster. Conforming the model to the placement of the camera automatically changes the number of triangles depending on how far the camera is away. To create the different detailed versions of models, if we use the complete version of XSI, we're going to use what's called the Polygon Reduction tool. Or we're going to use the Filter Polygons tool if you're using the XSI Mod tool. For now, we're going to work with the Polygon Reduction tool from version 5. With the model selected, we can go to Modify, Polymesh, and select Polygon Reduction from near the end of the list. When this opens, the default ratio will change to 50% of the number of triangles to around 2,500. You can still see the detail pretty well here. Now I can work at this level until I can no longer see the detail. Here we are at 0%, which is 5,400 triangles. And you can see how the number of triangles reduces as I step up. We'll work with the LOD controls. Here, we start with a default of 0, which is 5,400 triangles. And at stage 1, it reduces to 2,500. This is because we're working at a 50% reduction ratio. Now, every time I raise the number, it will reduce 50% of the triangles. But at higher stages, you can see that most of the character's detail has already been lost. What we're going to do is change the reduction ratio to 25%. This way, 1, 2, 3, 4, 5. We can export 5 models, and we only drop from 5,000 triangles to about 1,000 triangles, reducing 25% at each stage. So let's leave it at 0, which is our original model, and we'll export an SMD at each LOD stage. Valve source, export SMD, navigate to C, program files, Steam, Steam apps, your username, source SDK content, HL2MP, model source, humans, male, group 3M. And here, we're going to save it as NSC. Let's go to level 1 of our detail. That reduces 25% of the polygons, and we export. The file location is going to be the same, except we're going to add underscore LOD underscore 1. And we export. That's the first level. We export the same way with stage 2. Same with 3. Four. And 5. If you don't have access to the Polygon Reduction tool, you could go by hand and reduce the number of triangles and polygons by erasing edges, which could definitely take a lot of time. Or you can use the Filter Polygons tool, which works similar to the Polygon Reduction. Once I start working, you'll see the change in detail. And I haven't reduced quite as many polygons, but it still works. Go to Polygon Areas, And we start to lose a lot of detail, but, with a little patience it could work okay. Now, in the Program Files folder, Steam, Steam Apps, Noesis, or your username, Source SDK Content, Model Source, Humans, Mail, Group 03M, this is the QC file that I've originally used to compile. If we use it again, we still won't incorporate any levels of detail. In the Database Extras folder, NSC, under Compile Items, I have an NSC LOD QC file. It looks pretty similar to the one we were using before. But what I'm looking for are a couple of lines that read LOD7. This implies 7 metric units for the camera. Here, it will be at a level of detail 1. With twice the distance, it moves to level 2, 24, level 3, 35, level 4, and 60, level 5. These are metric units to the camera, and these are the only instructions that we care about. So let's compile using this new LOD QC. It's loading the 6 models, and it's starting to compile. In the meantime, I'm going to open another window. The SDK compiler is taking all the assets, our model, our texture, the animations, as well as the specific instructions that we've given and the attributes that we've outlined, and bringing them all together to create our character. Looks like it's still compiling. So let's navigate to Half-Life 2, Deathmatch, HL2MP, Models, and a C. And as soon as it's finished compiling, open it up with a model viewer. Switch to the Model tab, and here we have our Auto LOD. We have 5,400 of the original polygons. Now if I zoom in or out, it keeps the same number of polygons. So let's activate the Auto LOD, and now if I zoom in, we get to level 0 with 5,400 triangles. And if I zoom out to 7 metric units, it changes the level of detail to one with 3,900 triangles. There's level 2. 3, 4, up to 1,500 triangles. This is great because when the model is far away, we really don't need as much detail. So it can really help the frame rates, move and smooth throughout the game. And because the switch is automatic, it's really tough to see it happening, especially inside the game with multiple characters, running around and blowing stuff up all around you. You don't notice, but it really does help performance. Good. We've now seen how to create a 3D character, create a rig, export it, and then import it into the model viewer. Now we'll explain how to play your character in the game. To use our own character in Deathmatch, we have to replace the default characters that come with the game. This can be as many as 19 characters. 6 females, 9 males, 1 Combine Soldier, 1 Combine Soldier Prison Guard, 1 Combine Super Soldier, and 1 Police Officer. By replacing one or more of these characters, we can place our own characters inside the game. The process is actually pretty straightforward and simple. Basically, what we have to do is rename our compiled models or compile our own models with these names and save them into the appropriate folders. If they are male or female, they go into the HL2MP, Models, Humans, Group 03 folder, and if they're police or soldiers, they go into the HL2MP, Models folder. It'll also be good to create icons for each of your characters. This way you can easily identify each of your new characters. Male and female icons are both saved using the names of the existing characters. Male and female are saved under VGUI, Player Models, Humans, Group 03, and then the character name. Soldiers and police live under VGUI, Player Models. Now remember that anyone you want to be able to see your custom models will need to copy these folders to their local computer, whether they're connected to the local network or to the internet. The name of the folders has to be the same in each of the computers connected to the game. It'll be best to organize with the rest of the players which models will be replaced. Then save them in a shared folder where they can be easily copied to each other's computers. So this is what we're going to do. Let's replace one of the standard male characters, as well as the police officer, with our NSC soldier. For this example, we're not going to use any LOD, because it does take a bit longer to compile. So let's use the normal NSC QC file. And what I'm going to do is change the root to match the name on this page. Under model name, I will put Humans, Group 03, Male 01. This way, it will compile into Humans, Group 3, as Male 01. Save, and now we compile. In Models, Humans, now we have a Group 03, and there we can see Male 01. Before you start the game, I recommend that you check the model viewer to make sure the model is working correctly with all the textures. Looks good to me. Let's do the same thing with the police. I'm going to copy this to the directory for soldiers and police. It's already compiled. Models. Let's put it here. And we'll rename all these files to police. Make sure that they're all named the same. Now let's replace the icons. Go to your DB Extras folder, NSC, and there's already a prepared icon for the soldier. Save it in Materials, VGUI, Player Models. First we have the police. Then in Humans Group 03, we name it Male 01. So let's check it. Humans, Group 3, and then Models, Soldier, and Police. Alright, let's try it in the game. Here we are again inside Deathmatch. So let's go to Options, under Player, select Male 1, which is our new NFC soldier. He's also listed under the police. We can choose whichever we want. Click on Play, resume the game, and just like the last time, let's go kill ourselves so we can get a better look. I'll toss a big dumpster straight up. You can see yourself inside the game. A complete replaced character. Let's do it again. This time, we're using a grenade. So let's see, we'll do them in the corner here. Boom. And you can see our 3D model. Alright, this time again, we have a server running with another computer loaded up with the same models and materials as mine. So now we can run around and check out our model in a bit friendlier fashion to make sure everything is how we like it. It's kind of fun. Can zoom in, run around, and he'll see me just the same. We could even give him a whack if we wanted to. So in this way, you can go through and actually replace all the default characters within Deathmatch game with your own creations. So now let's run through the entire process again with another character, since the entire process should be a little bit clearer this time around. Open Database 201 in your browser. Under Models, choose Bot. You may recognize him from the modeling exercise in our previous disk. Then open Photoshop, and we'll create his texture. Under Extras, choose bot.tga. And we're going to save this in C, Program Files, Steam Apps, Username, Source SDK Content, HL2MP, Material Source, Save. Now in XSI, assign him a Fong material. Then in the Render panel, select Texture, Image, New from File. And let's select the TGA. Program Files, Steam Apps, Username, Source SDK Content, HL2MP, Material Source, Bot. There we are. And once he's modeled and textured, go to the Valve Source menu and choose Characters Biped Guide. Scale our bot up to match. Align the feet. And remember to freeze all transformations. Now we just adjust the rig to match our model. Keep in mind that the better you align it now, the better the movement will be later. So go to the side view and make a few more adjustments. Check the top, which looks pretty good. So now we'll go to choose Valve Source, Characters, Create Rig from Guide. Takes a few seconds to populate all the controls. Close the windows. 8 to explore. Select the bot model, and let's set the envelope. Deform envelope, set envelope. Click yes. I'm going to click on the envelope deformers, right click to exit. And now we're ready to export our SMD. Valve source, export SMD. And we'll place the file in the same location as before. Steam, Steam apps, username, source SDK content, HL2MP, model source, humans, male, group O3M, bot.smd. Export. Whoop, we've got an error. Select the script icon and let's see what happened. And near the bottom we see the XSI file is not currently accessible. And nothing has been exported. Alright, so go to our hard drive, temp. Let's see, we're probably going to have to change our folder options to view hidden or system files. And now we'll see the underscore temp.xsi file. We actually have to erase it. Then we can go back into XSI and export again. The file path should still be in there, so click OK. Good, and this time everything worked just fine. Alright, navigate to where we export our SMD. Program files, Steam, Steam apps, user, source SDK content, HL2MP, model source, humans, male, group O3M. In another window, open up the materials source folder. And we need to compile the TGA we saved out of Photoshop. I drag it to the vtext.exe. And once that's done, let's create a QC file called bot.qc. Leave it open a sec. In the DB extras folder, copy the QC information from the sample QC file into your new bot.qc. Paste. And all we have to do is change the model name path from humans to models. Bot. Bot. And the materials path to models. Bot. Change the name of the model. Bot. And the name of the file. Bot.smd. Alright, now all we need are the materials. So go to Half-Life 2 Deathmatch, HL2MP, Materials, and inside the Models folder, create a new folder labeled Bot. Inside that folder, create a new text file with a VMT extension called bot.vmt. Good. Move that aside for a second. Open up your extras folder and copy the information from inside the sample VMT material file. And paste it right into the bot.vmt file we created. Change the generic texture name to bot. Save it. And now we should be ready to compile our QC by dragging it to the Studio Model executable. When it's finished, navigate over to the Half-Life 2 Deathmatch, HL2MP, Models, Bot folder, and open up the bot.mdl inside the model viewer. Left mouse button to orbit, right mouse button to zoom in or out. In the Sequence tab, you can scroll through the various animations and poses to see how your character will look, holding his different guns, or just sneaking around, and he's ready for the game. Let's run through another example for importing characters and talk about some of the problems you may run into. We'll open up a scene, go to Program Files, Steam, Steam Apps, Username, SDK Content, HL2MP, Model Source, Humans, Mail, Group 3M, Scenes. Okay. Here we have mail5 reference. So let me tell you that file path once more in case I ran through it a little too quick. C, Program Files, Steam, Steam Apps, Username, Source SDK Content, HL2MP, Model Source, Humans SDK, Mail, Group O3M, Scenes. Open up Mail05 reference. And I've switched to using the mod tool version for the moment to illustrate a couple issues mod tool users might face. Alright, this is a base scene that comes with the SDK. What we're going to do is import a model, scale its proportions, and work with the weight maps. So let's import a model, File, Import, .xsi. And under DB201, in .xsi, and we have our Catwoman. The first thing you'll notice is she's a bit smaller. We have to freeze because she has an applied texture. So freeze the model. And now let's scale it. Something like that. Now with the first model, let's go to Valve Source and export its weight map. Place it in the root directory or somewhere it's easy for you to find. And export. Now erase the male character with delete. And now we just have our character. Import. Takes a few seconds. And there we have it. You can see that the skeleton is not connected. but we do have the weight map, which is what we want. Let's just smooth it out a bit by bringing up the neighborhood depth. Now, with our model selected, go to Valve Source and export SMD. And I'll just put it in the root of my hard drive since we're going to move it in a second anyway. Okay. Catwoman is exported. There we go. Now wherever you saved it, find the catwoman.smd. And for consistency, let's move it to the same directory that we've been using. Source SDK, model source, humans SDK, male, group 03M. That way, we'll still be working with the existing animation library. Now I have to create a .qc file. In the extras folder, Catwoman, just move the .qc file to the same directory. Open up and take a look at the QC file. It's very similar to the other QCs that we've used. Here's where we can change the name of the object that we're going to create, and we'll give it textures. Now let's compile it. And when it's done, it should show up in the models folder. There we are. In Deathmatch, models. You'll notice that when we open it in the model viewer, we see something very strange. She's just sort of flopping around all over the place. And I'll explain why in just a second. But I want to show you what it looks like in case you run into a similar problem. What's happening is, if you can remember from other scenes where we've scaled characters, looking at the transformation values, they are not 1, 1, 1 like they should be. We could simply try to freeze our transformations, but let's see what happens. Transform, freeze all transformations, and because of our weight map, the scale comes back up and multiplies. So undo, and let's do the following instead. With the model selected, open your Explorer, let's look for the envelope operator. Select it and erase it. Now select the object and separate it from the hierarchy. We want to break it completely from the hierarchy. This one here is a null. We can just erase it. And now you'll notice the new transformation values, correct values. So now freeze all transformations, and you'll see that it goes to 1, 1, 1 in our scale. So now we'll re-import the weight maps. And export an SMD. Copy the QC. Compile it. Takes a few seconds. Open her up again in the model viewer. And there it is. Now what if I want to go back and add geometry or otherwise just change my model? In XSI, select File, Import .xsi, and we have some wings that we'll try to add on, adding them to the existing geometry. First, remember to freeze the model to preserve the texture. Then let's cut it from the hierarchy so that it is not parented up to anything. Place the wings where you think they should be. I'm going to scale them up a bit. Somewhere in there. Pull them back a little bit. Then align them up on her back. And maybe make them a little bit bigger. And freeze all transforms. Now let's take the two parts and choose Polymesh, Merge. Adjust the tolerance, or use the blend option if you need. Then merge all attributes and delete the inputs. Now we'll re-import the weights. Weight map import. The correct file is already selected. It's going to try and assign values to the wings. So we'll check to see if they're okay, and if not, we can correct them. There we go. The wings look to have values assigned from the hands and the shoulders. I'm not sure that's really what we're going to want. But let's compile it and see what happens. Save your scene, valve source, export SMD. And when it's all done, we'll navigate over to the SMD. Yep, this is important. This error message is telling us that we have passed the limit of triangles. Now, if you remember, the mod tool has a compile limit of 7,500 triangles. And here we have 7,900 triangles. So it's going to crash. So if you saved your scene, just open it right back up. I'm just going to have to redo the last few steps. Select the model and wings object. Let's merge. Adjust the tolerance. Merge all. Close the property editor. Whoop. 8 for Explorer. Select the polymesh, polygon mesh. Click the merge meshes operator. And I'll delete the inputs. Alright, switch to the textured view to see how the texture is working. And let's look at the weights again. Locate your weight map. Import. Alright, this would be another good time to save. And now, before we export, let's get rid of a few polygons. Select the model, and we'll filter out some of the polygons. Model, Modify, Polygon Mesh, Filter Polygons. And we'll just make a few adjustments here under Incidence Angle. Leave the window open while we check to make sure we're not losing too much detail. And you can see the results as you move along the slider. We could bring it all the way up to 3 or 5. And it looks alright. But I don't think we really need to be that extreme. So I'm going to select the model and bring it down so that I'm just under the 7500 polygon limit. There, somewhere around 1.8. Now it's ready to export. Valve source, export SMD. And I'm saving to the root of C. Copy the new SMD into the group 03M folder. The QC file should be ready. Double check, and then drag it to the studiomodel.exe. When it's done, the model appears in the HL2MP Models Catwoman folder. Open it up, and we'll check to see how the default weights have worked out. Orbit around using the left mouse button to see how everything looks at rest. And it looks like the wings may have too much weight assigned in here, which causes them to get kind of pulled down and deformed. If we check out some different positions, we can see that the wings are actually changing with the position of the hands. And they get kind of pulled around at all kinds of odd angles. Not really the results that we were looking for. So let's fix it. Switch back to XSI. With the model selected, select some of the triangles of the wings. Then under Select, choose Grow Selection. It still hasn't gotten all the points, so middle click to grow the selection again, and keep middle clicking to grow your selection until we have all the wings selected. Now go to Select, and select Adjacent Points. It's going to be a bit easier in wireframe mode. Let's assign those points to this bone, which is the spine, the yellow bone. Go to Animation, Envelope, Local Reassign, left click to select the bone, and right click to end the tool. Now we can see the weights for the wings have all changed to yellow, and they will no longer be influenced by the arms. So export, and copy the SMD to the correct folder. Grab the Catwoman QC and compile it. Open the .mdl in the model viewer, and that moves a lot better. Just check out the wings. Make sure you check out the whole sequence, test out the rest of the animation library. And this is where we can really see the importance of the scale of the object. If they are parents or children of objects, they should all have a freeze on their translation, rotation, and scale. The model viewer really allows us to see how our models will behave inside the game. So in case we want to go back and modify our model in XSI, we can go make any adjustments and then quickly see how it's working in terms of the weights and animations, until we have a model that we're really happy with. You can test out a lot of attributes, view the movement space, look at shadows, check out all the different types of walking, different gun holds and positions, all before we even launch the game. Hitboxes are boxes that surround all characters to determine where they can receive damage. They are attached to bones and belong to different groups. These groups are divided into numbers and colors, each of which determines the amount of damage it can receive from an impact. For example, we can see that each arm belongs to a different group, as well as the legs, the pelvis, the chest, and the head, which is one particular box that is more vulnerable to taking damage. Before we get into hitboxes, you need to first copy the contents of the two folders within your Database 201 Extras Noesis bot folder, and we're going to copy them into your username folder within Steam on your local hard disk. So from the Extras folder in Database 201, open the folder Noesis bot with Steam user in parentheses. We're going to copy these contents, these two folders, to C, Program Files, Steam, Steam Apps, your username. In this case, it's Noesis 3D. And we'll copy those two folders right here into your username folder. Wait a few seconds while everything copies over. Now let's explore Program Files, Steam, Steam Apps, username, Source SDK Content, HL2MP, Model Source, Humans SDK, Mail, Group 03M. These are the files we're going to use, our level of detail and QC file, and in Half-Life 2 Deathmatch, HL2MP, Models, Noesis. This is the Noesis bot that we can open up in the model viewer. So make sure you have Steam running and the game is set to Deathmatch in the Source SDK. And let's open the Noesis bot MDL in the model viewer. Turn on the hitboxes, and note that by default, this model uses standard hitboxes which are calculated automatically when the model is created. The compiler actually uses the reference skeleton to add hitboxes to the bones. We will have to customize these hitboxes to account for our character's larger head and wings, since there are no bones in these areas. So let's go analyze our model's QC file a bit closer. In the bottom portion of the QC file, we have an instruction that calls for the hitbox.qci. You can find the QCI one folder up from the standard model source humans SDK mail group 03M folder. And here you have the hitbox.qci. It's a text file where you can see the hitbox, the number of the group it belongs to, and which bone is applied or attached to, as well as the exact position in which the hitbox should exist. To create a similar table for our custom model, who needs custom hitboxes, we're going to enlist the help of the model viewer. So open the Noesis bot.mdl again in the viewer, and check the box to view hitboxes. Switch to the Bones tab, and select the option Highlight Hitbox. Now, when we go down and select a bone from the drop-down list, it may also be helpful to select Highlight Bone. In this case, you'll see the spine doesn't have any assigned hitbox. If you switch to Spine 2, you'll see it has one hitbox, which is the chest. Here are the head, arms, and legs. Now if we look at the colors, you notice that they are related to the group numbers they belong to. Group 1 is the head, the group that will receive the most damage. Then there's the right arm in group 5, left arm, group 4, etc. To modify the hitboxes, first select the bone. We'll start with the head, and then we'll stretch the box to make sure it completely surrounds the entire head area. These 6 boxes will determine the hitbox origin and the hitbox size. The first number, let's change it to 15, adjust the height in the global Y value. The second box sets global Z position that can be positive or negative. And the third box is the global X position, negative, positive. So the X, Y, Z values next to the boxes are relative to the bones the hitboxes are attached to, not global coordinates. The same with the hitbox size. If you enter 50, this is the size in global Y value. And in global Z, or depth value. So let's enter a number that is going to cover the entire head. And finally, the width of the hitbox. This is how we cover our custom head. Now let's add 2 more hitboxes that will cover our wings. We need to find the bone to which we can attach our new hitboxes. The head, the clavicle, arms, So let's select the neck 1. What we're going to do is add a hitbox. And let's position the hitbox over one of the wings. It may take a little bit of trial and error. Lower it a bit. Move it back a bit. And to the left. Now scale it. Maybe make it a little narrower. And now we have to assign it to a group. In this case, the right arm. If you look at the right arm, you'll see that it's in group 5. So return to the neck, select hitbox 17, and let's change the group number to 5. This way, it will receive the same amount of damage as the arms. Good. Now let's repeat it for the other wing. Select neck 1. Add a hitbox. Let's set up the origin. A little bit down. Back a bit. And to the right. Making it a bit smaller. And narrower. Now let's check our group number for the left arm. It's number 4. Go back to neck 1. Switch to our new hitbox 18. And assign it to group 4. The model viewer helps us to place these hitboxes. The next step is to recompile the model. Go back to the Bones tab and click Generate QC. When you select Generate QC, it actually copies the hitbox values to your computer's clipboard. So now, open up your existing QC file and we'll replace this line of code with a new custom hitbox file that we will create called hitbox Noesis bot.qci and save. So let's actually create the file. Right click, new text document, name it hitbox Noesis bot.qci. Open it, and let's paste in the contents of the clipboard that we generated when we selected Generate QC inside the model viewer. It's actually a very useful feature inside the SDK. And finally, now when we have all the pieces in place, let's actually compile the model. Once it's compiled, we can open it in the model viewer, take a look at its hitboxes to make sure everything appears in order, and there you can go. You can see each of our hitboxes applied. Let's talk about character scaling. This is also very important. Because we're going to be using the standard animations that come default with the various existing characters in Half-Life, we could have some problems with scale. In this case, you see two characters. One with the standard default rig scale, and one with the reduced scale. If you notice, they are actually both using the same rig. Both rigs came from the Valve Source character Biped guide, but the second was reduced to match proportions of the second, smaller dwarf character. If you look at the compiled model inside the model viewer, some poses will appear correctly at the smaller proportions, but with other poses or animation cycles, let's choose Run RPG, you'll see the character gets scaled up to try to match the standard animation size. All the bones actually get stretched to try and match those of the standard scaled characters. This is important since this is actually how the guy would look inside the game. And it's making some proportions of the body very awkward, and isn't at all what we had in mind when we were designing. It is possible to create our own custom library of animations for each of our characters. I've got an example here of a new custom walk cycle. After we compile it, the sequence appears within my animation library. And it works pretty well. And here's another example of a compiled sequence I've created. There are also tools that will help us to convert animations from one character to another with a different scale. We do discuss those tools in depth during the Advanced Character Design lesson series before getting into creating your own completely unique character animation sets. But for now, if we choose different animations, they are still referencing the standard character animations. But I did want to show you an example of what's possible so you can start getting some ideas together. For now, be careful when you're dealing with characters of varying scales. We can also create our own custom animation sequences, but they will only be accessible from within Half-Life, not necessarily Deathmatch. All the process of creating custom animations and sequences in XSI, exporting them, and then importing them into Half-Life are actually covered in Noesis Advanced Character Design